So hello everyone, once again, Nicholas here, your host at Altair Insight Podcast. I want you all to be prepared. Today we're in for a quite important insights, I believe personally, as we're joined by Joe Latrell, who again is an inventor, a technology developer who has coordinated payloads for launch on the SpaceX Falcon 9, Blue Origin New Shepard, and Rocket Lab Electron. So the big three, right? And now he is the founder of the Quub space, which we're going to talk about in detail. Prior to Quub, Joe gained wide-range experience in a variety of technology roles, such as launching an early-stage suborbital rocket company. Very nice. We're going to talk about that as well. Coding programs for large datasets and developing numerous software packages for the education industry. More about the Quub space. So that's the company manufactures small, cost-effective satellites designed to gather data and monitor Earth, its weather systems, and its environmental resources. His goal is to create a network of satellites that give first responders, companies, and municipalities the data they need to respond and act quickly. So very noble and important mission, again, that Quub is working on. So hi, Joe, once again, pleasure to have you on.
Hi, it's a pleasure to be here. Thank you.
Perfect, wonderful. So we read, quite a lot about your bio here. And again, you've coordinated payloads for launch for SpaceX, aboard SpaceX, Blue Origin, Rocket Lab, and that's just wow, right? And another thing that I found very interesting. So first of all, let's start with your personal journey. So how you came to be in the space industry and what urged you to create first this rocket suborbital launcher company, because that was prior to the Quub, right?
Yep.
Yeah, so we can start with that right from the beginning. So your background from the education perspective and all the way, just lead us to the beginning of the Quub space.
Okay, well, Quub actually started, if we set the Wayback Machine into the 1970s, I watched the Apollo landings, but I really got hooked after the Apollo Soyuz test program. I watched that live on TV, and it's like, I want to be involved in space. Of course, the world didn't see it that way at that time, so I became a carpenter. I worked in construction for a while, computer software development in the 80s and 90s, web development in the 90s. And then tragedy struck. My youngest son died of SIDS, and I wanted to do something to remember him by. It was very important. And so I created a company the company evolved out of that called Beyond Earth Enterprises. And the idea was we were going to build inexpensive access to space, cheap access to space. And it didn't work because, in 2003, there was the perception of NASA and this little itty bitty company called SpaceX was there, but there really wasn't a lot going on in the industry. If you said, hey, I've got a rocket company, most people would laugh at you. So we did that for a few years, closed it in 2006 after some success, mothballed everything, still have all the hardware from it, and moved on. And that's when I went into more computer software again, ran a software publishing company. I designed the back end for a school for 6,000 students, did a little time at FedEx, MapQuest. Not the reason why you got lost. I did those kinds of things. And then I saw in 2009, 2010 timeframe, I think that's about when I first came across this idea of a pocket cube. Like, there's no way this is going to work. Well, in 2013, I go and revisit it. And I was like, yeah, I think I can make one of these. So I 3D printed a pocket cube frame to see what could be done. That took a little bit of time. But once I got that, I was like, all right, now there's no electronics yet that will fit in here that will work. And when I say small, a pocket cube is 50 centimeters on a side, or 50 millimeters on a side. Okay. In 2015, the hardware started to look promising, so I started to build one out. Unfortunately, Intel canceled the hardware that I was working on, so that was a no-go. And then in 2017, I get a phone call from Tom Walkinshaw over at Alma Orbital. It says, "Hey Joe, I know you're into these pocket cubes. You want to fly?" I'm like, yeah, right. He says, "No, do you want to fly?" I'm like, okay, well, sure. So I go to the Pocket Cube workshop. I see that there are about 70 people worldwide who are interested in doing the same thing I am. Like, all right, let's make it happen. Signed a contract, and I started work on an official Pocket Cube satellite, which this is it.
Oh, and
This
that's
is
the
actual
original, by
satellite.
the way. That's a copy of the original, right, for the individuals. Yeah.
This is the original.
Oh,
It
okay.
wasn't. Yeah. It wasn't allowed to fly. Licensing and regulation are very difficult at this scale, and I wasn't quite ready for the challenge. And it took way longer than I thought, way more money than I thought, and it just did not come together in time for launch. So, you know, things happen. 2018, I decided I think I can do this as a business. Formed up a limited, you know, just basically an LLC, and started work part-time. My wife and I was working at a desk in my basement, and the wife says, nah, maybe you should move out of the basement in case you blow something up. All right. So we converted our little, yeah. Well, I also play around with high power rocketry, so it was probably a good idea that I moved out of the basement. And we set up an 160 square foot studio that I built in the backyard, and worked in there for a little bit. Then in 2022, I effectively, you know, did not have a job. My job went away. I said, I'm going to jump into this full time. We've got enough money to get to April. That's it. I had a 4-month runway. All right. Let's see how far we can go in 4 months. April, we still had money, so I kept going. And I kept going and kept going. And we moved out of the studio into a 600 square foot facility. And then we moved into a 2,500 square foot facility where we're at now. And we're looking at building out a 20,000 square foot manufacturing facility. So what the resources that we've needed have always shown up exactly when we've needed them. And so we've kept going. And we launched a total of 3 satellites. One was on the first Firefly Alpha. That one, as we all know, didn't make it to space. I launched a Challenger version of our satellite on SpaceX. That one we never got signal from, but we did a fault tree analysis, found the problem, and fixed it. And then our third one was launched on the second Firefly Alpha, and we got signal back. We knew where our satellite was. It's like, yes, this is what we want. So we know our technology works. Now we're going full speed ahead with building out our network.
Perfect, wonderful. And again, stories like that, and I'm very grateful again personally that we are able with Altair Insights to showcase stories like that really can inspire this, you know, entrepreneurs of the next space companies, right? Because as you said, you started at a time where the industry was not yet at a stage to support again this pocket cubes and, you know, the micro satellites to that extent, to that small, right? One of the like companies that really like showcased that was Planet. They also started back in the garage. So you started in the basement, right? So that's a similar story as well. And that's, again, awesome to see. It also showcases those risks that are associated with the space industry, with the, again, first satellite and the second satellite not working out for different reasons, obviously. But again, you made it. So that's one of the true values that we also you know, enforce within our podcast and our other activities within the company, which is perseverance, right? So you have to persevere long enough and try hard enough to come up with a solution and achieve success in your journey. But one thing I liked a lot, Joe, when I checked again the Quub website, earlier today I was like crawling the website, checking everything you have there. So by the way, I encourage everybody who's watching this to check out this as well. So it's Quub.space. So QUUB.space. That's a website, and that's not changing anytime soon, right, Joe? That's gonna.
Oh no,
okay.
No, it's gonna be Quub. That we are Quub.
Yes. So I encourage everybody to check that out. They have a cool little video there as well. That really showcases what they're working on. But one thing that caught my attention, Joe, was that you stated that you are not a space company, you are a data company, right? Which I found very insightful. Again, there's this misconception that's happening outside of the industry, that space industry is like a bubble, and space companies are only serving the space companies and so forth. And I believe that's also one of the points that you have. And I want to see if you have any other meaning behind this again, and maybe you can expand on this.
Yeah. When people think about space, all right, space is, what we've done in space is put a bunch of tools up there that provide us information. Some of that information is about the cosmos, Hubble Space Telescope, James Webb Telescope, all these different instruments looking out. But the bulk of the satellites that we've launched look back on Earth. So there's a lot of data that's collected. What do we use that data for? Well, we use it for climate analysis. Your weather report that you see on the news every night, or if you go to a website and get your weather that way, all of that information is created via satellites. That's the key data set that's used for all of this. If you're doing climate modeling, you're using satellites as well as the ground stations. There's a whole bunch of things that come from using satellites, but it's all data. So we say we're a data company because our objective is to put a constellation up that gathers data, analyzes that data in as close to real time as possible, and then we shuttle that data to the people who need it most. That's a complete business cycle. The satellites are great. The satellites are cool. We love building them. We love hanging out in our clean room and making things happen. It's fun to do, but ultimately they're a tool. A satellite is very similar to a hammer or to a computer. They do a job. Our satellite's job is to get imagery, a multispectral image, back to us so that it can be completely analyzed and get that information into people's hands where action can be taken.
So you're actually building an ecosystem. You're monitoring all those different aspects, right? So if it's for the forestry or for the climate or for the emergency response, right? And basically then you're monitoring, you're tracking this with the software. I'm just trying to break it down to the audience here. And then you receive notifications when some of the parameters, they are going out of the, norm, right?
Yep. So on the satellites, we have what's called the low resource machine learning. It's not what anybody's thinking like Chat GPT or AI or anything. It's a very low resource system. And the idea is to look for differences, anomalies. So let's say we fly over a section in California. And the first time we pass over it, there's nothing to see. But the next satellite that passes overhead notices there's a change. It identifies that there's a higher temperature at a spot where there wasn't one in the last data set. It says, oh, something's going on. It identifies those GPS coordinates. It sends that information down across our network. And then anyone who is subscribed to that network, I mean, we have to make money somehow, they receive a notification. It can be as simple as a text message saying there is an incident at this GPS coordinate, you need to check it out. And this would allow the Forestry Service to be able to get eyes on forest fires much sooner than they can under current conditions. They still use lookouts. I mean, there's still people up there with binoculars scanning forests. That's still a thing, but we can scan them better from the sky. But the data also works because we're looking at anomalies, we're looking at changes. This information can work just as effectively in water quality management. I spent 3 years in water quality management. I engineered a lot of solutions that covered 8 states, and there are things that you can see happen to water when there's a problem. Again, mainly a temperature change. So we look at that temperature change and we can say to anybody who's downstream, hey, there's something that happened here. We don't know what, but you might want to be ready. This will allow water treatment facilities to close their intake valves, get their chemical testing set up, be ready for whatever's coming, be it a flood surge, which we can monitor, again, temperature change, or we can see that there's been kind of gross here, a raw sewage dump right into the river. I know for a fact that raw sewage is at a much higher temperature than regular water. and we can spot that from space. So why not spot it from space? And so that's what we're doing. So anything that's an anomaly is the focus of what our company does. It's not the actual images. The pictures are great, and we do bring those down, but it's that shift when things change. That's what we're looking for, and that's what we use to identify and get it to our customers.
Great. And for the audience, so your capabilities are able to do that every 15 minutes, right?
The objective is to have a constellation of 400 satellites, which would give us revisit times of 15 minutes. So the first satellite passes overhead, 15 minutes later, there'll be another satellite coming close by that will be imaging that same area. Yep, that's the idea, is have 400 of these constantly in orbit, constantly looking at things. And just to alleviate some potential fears, we're at 5 meters per pixel. So we're not looking at license plates. We're not seeing you in the backyard. That's not what we do. Okay, we're interested in what's changing in the soil, in our forests, and in our water.
Perfect, wonderful. So you also mentioned earlier, Joe, regarding the licensing and regulation, and that being a thing that again slows down a lot of space startups. So I know personally from many conversations that I've had. So how were you again able to overcome those licensing and regulation problems, and how has that affected the cycle of your satellite development?
Very good question. So yeah, the secret to dealing with regulations is to know people who know regulation. Okay, so we work with a group that specifically provides our regulatory components. They get paid, and we tell them this is what we're working on, this is what we're trying to do. We put together the regulatory package, we submit it, and they stay on top of it. If you go it alone, like if you want to start a satellite company, you want to launch one of these on your own, I encourage that, but be prepared for a 12 to 18 month time lag in the process. And there's a lot of legalities you need to know. Just put together a network of people who already have those skills, and then use your network to make those things happen. That's how we overcame the problem. Again, the first time we did this, we missed. It's like, okay, I'm not having this happen again. If this is going to be a business, it has to be run as a business. And so we found the expertise needed for all of the things that we need to do, from regulatory, engineering, compliance, manufacturing. All of those experts are either in-house or as consultants to this company.
Wonderful. And you mentioned again that you're working with different type of stakeholders, right? That would be the first responders, governments, the corporations, right? So, my question to you regarding that point is, how do you communicate that to them, right? Because sometimes we see that as a problem. Maybe in the United States, not so much, because the level of the awareness in those adjacent industries seems to be a bit higher. But especially in developing countries, which, third world countries, which are not really aware of the applications of space data into their segments and industries, how do you approach communicating that? First of all, do you approach communicating those, or you only focusing on the national US market? And if you were, how would you do that? That's a question.
Yeah. So we are focused on the United States to start. We've got 16,000 potential customers just in water treatment facilities alone. So we're a bit busy, but any country that's developing should be on the list. And we know that that market is a little harder to break into. We're looking at putting together regional representatives for Quub they know the area, they know the conditions and the situations that particular country are experiencing because they're from that country. And we want them to be the point of contact. So that way, it's more of a personalized kind of a sale. We're trying to help. So here's some data that will help you and keep the pricing simple enough to where we can do that. So yeah, we know it's a hard market. We've started looking at additional markets like Canada and Brazil as our second and third target. And then we're planning to migrate everything over to the, I would say the African area. That continent will be next on our list, and start finding the folks who can use it. And again, developing countries, if you want to know what your resources are doing, it's a good idea to have a monitor on them that's independent, that doesn't rely on the ground or getting to it. It's a, here's a web, you have a website you can log into. We have a portal we're building. You can get all of your information there if you don't have SMS capabilities on your phone. So yeah, we're working on developing those tools. It is not an easy market. We know we've got, it's so uphill, it might as well be vertical kind of problem, but we know that it's a challenge, and we intend to accept that challenge and conquer it.
Absolutely, and again, you're doing a good job with communicating that. The fact that you're here, that already states it, that you're putting the time into awareness and communication, and communicating it directly to those consumers and on their language, right? Because as a business owner, you have to speak different languages, right? You have to speak different language to your, partners, to your vendors, to your investors, to your clients, to, again, your family, right? So it's different languages that we have to communicate. And again, it's very important and good that you're doing that. Because a lot of companies are not utilizing that in the space industry. The social media, the virtual events, they're not really putting much thought into this, even though it's to their peril, really, because with those developing countries, if we're discussing, we do not really see them at the events that, some events that happen in Paris or, Dubai and other places. I mean, this is not a place where you reach those individuals who are from developing countries, because they cannot afford to travel there. They're simply not there, right? So you have to find other venues to communicate with them. And again, appreciate you for putting the time and effort into doing that as well, and investing time in those things. So my next question is, so how does Quub Space ensure that the data collected by its microsatellites is accurate and reliable? Obviously, that's one of the big questions always when we're talking about the space data and remote sensing.
Yeah, that's the other advantage of having a frequent revisit time, is that the satellites themselves are a self-checking mechanism as well. So first satellite passes overhead, hey, I see an anomaly here. Second satellite passes overhead, says, yeah, I still see that anomaly. Third satellite passes overhead, says, I don't see it. Okay, well, you got 2 out of 3. Usually that's good enough to say we have a high probability. So does that extend the time before information is sent to the ground? Yes, it does. But first satellite passes overhead, doesn't see anything. Second satellite sees something, notes the anomaly, sends it down to the people who need to check it. Third satellite passes overhead, notices that there really wasn't anything there, sends, hey, disregard the last message. We're not seeing the anomaly anymore. So self-correcting, self-healing system, you have to go with that. Are there going to be false positives? Yes. Are there going to be false negatives? Yes. The idea is to have as much data overlaid as possible so that you get an accurate picture of what's going on. And it's real easy to launch a drone and fly over a farm and you see something while you're up there. But what happens if there's actually a problem with the soil that is occurring only in the afternoon, like you're watering in the morning, you're not catching that the soil's drying out to a level that's not good for the plants, and stressing them out. Well, if you use the drone once during the day, you don't see that. But multiple items, multiple sensors on it, then you can start to see those changes and understand what's going on.
Okay, perfect. Yeah, that's clear as well, right? So the next thing that I liked when I looked up again the information regarding your company, I tried to find as much as I could, and obviously I couldn't get familiar with all of it. But I know that your satellites, they are developed mainly from off-the-shelf components, which again really positively affect the development costs, as well as they affect the the timelines for developing the satellite. So how important is that again for you, and how would that look for you without off-the-shelf components? So how much longer would that take if we're talking rough numbers? Then you can tell us about the schedules for your 400 satellites. When is that?
Okay. Yeah. Commercial off the shelf makes this even possible. If we had to custom design every last piece, then you're looking at about 5 years development time for a single satellite bus. You can start to build a factory like what Starlink has done, and they're cranking out satellites fairly quickly. It's a huge process, but there was a lot of capital spent at the front end to make those satellites a possibility. We still have that capital expense, only it's not as high. Mm-hmm. And by using off-the-shelf components and some of our own proprietary secret sauce, we can make a satellite work just as effectively at roughly between 10% to 25% the cost of an equivalent satellite. That's makes it possible for us to. Our data is cheaper because our capital expenses are cheaper. That gets data into more hands that can use it. So yeah, off the shelf is very important to us because it keeps the costs down so that we can provide a quality product at a price that a municipality can afford. A lot of governments are strained on how they can spend their money. Early warning systems is not high on the priority. We want to make it cheap enough so it can become a high priority. And if a wastewater treatment plant has information that saves them $20,000 for one incident, and that's not uncommon in the United States to have incidents that cost that much, but it only costs you, say, $100 a month for a subscription. 1,200 versus 20,000. See, now the numbers make sense. Yeah, that's the idea. So commercial off the shelf makes that possible. We're using materials that are also, unheard of in space. And this satellite was 3D printed. Okay, this was grown using a laser sintering process out of a material that is rated for space. We could iterate this design 4 times in a week, test it here, and go to final print and have them the next week. No machining, we go straight from our design software to 3D print, and we're done. So our development time is also shorter. It's allowed us, our current satellite iteration is somewhere up around 18 or 19 that we've been able to do since the start of 2022. Okay. We also build like Legos, off-the-shelf components. Let us build these like Legos. So a new sensor comes out, we just have to work around the new sensor and not redesign the whole satellite.
Wonderful. And how high above, what is the altitude of those satellites that they're deployed on, and what's their, again, lifetime?
We try to deploy about 500 to 550 kilometers. We're in a sun synchronous orbit, so mostly polar, and we have a 3 to 5 year lifespan on our satellites if we don't have propulsion. We do actually have propulsion on board our satellites, which it can be used in one of 2 ways. It can be used to extend the life of the satellite, which takes us to 5 to 7 year lifespan, or it can be used to deorbit the satellite. So we can force it into the atmosphere faster. That's just, it's a good idea to keep the environment you're working in as clean as possible. Don't pollute another environment trying to monitor the one you're in. That it just stop. We don't need to be creating extra debris, extra space junk. So that's the way we want to do it. In order to get our 400 satellites up, we're going to have to launch in different tranches. So we're expecting to put 24 up over the next year. Then we're going to launch 100 after that. Then we're going to launch 200 after that. Then another 200, and we'll then start to replace at 100 satellites a year. So one launch every year keeps our constellation fully functional.
Quite fast.
Yep.
Yes. Okay, yep. That sounds good. That sounds amazing. So the next question I have, Joe, which is, again, there's been a lot of disturbance regarding this topic, which is cybersecurity, especially after the Ukraine-Russia war began and a lot of those things started. My question to you is, Joe, so how does your company prevent somebody hacking into your, again, database system, bypassing your firewall, and then sending those false alarms to all of your customers, right, regarding the emergencies?
Excellent question. We do that. Okay. The problem is that you have the castle. This is called the castle problem. So we have all of our data here and it's in a castle. I have to find every way to block people from getting in. But if you're outside the castle, you only need to find one little hole, right?
Yep.
So that's always the problem. So we use a double encryption system that we've developed here that is proprietary. We do have a couple of other secret sauce elements that I can't talk about.
That's fine.
But yeah, and because I've worked with large data sets before and very sensitive data, I mean, I built the back end again for a school, 6,000 students per year. That data needed to stay secure. So I understand a little bit about that, but it's better to hire somebody who's more of an expert. And so Phil, who's on our team, he's a data expert. He understands this. We also have Kyle, who is a security specialist. So these two guys get together and they say, all right, how are people going to try and get this data? And they actually run hacking exercises and drills. They try and break into our own systems. And if they can do it, well, then I give them a bonus and say, good job, now plug the hole. So we are doing that. But right now, the encryption system that we're using is state of the art, and I'm not too concerned about it. We keep all of our data here. It's not on the cloud. We know that we're going to have to move to the cloud, in which case we'll be looking for a provider who can actually work with us with the encryption techniques we're using. As far as getting to the satellite and getting data, that's going to be a little more challenging. Again, we have standard radio frequency, but we also use optical communication that's in development. So you'd have to intercept the laser beam, and that becomes quite a bit of a challenge. That, along with our encryption, double encryption between the satellites even. So unless you're in the network and you're known to be in the network and you've been authorized on the network, you're not getting data. It's that simple.
Sounds very secure to me. I mean, good enough. So, and it also like depends, obviously, the different type of stakeholders, they have different type of, requirements for, but I'm sure you're all good with that and you're meeting those requirements perfectly. So, that's good to see, good to know that we're safe without false emergencies. So that's good.
Yeah. And we also know that our data it has a limited shelf life, right? If you're doing anomaly detection, it's only good for today. It's only good for now. Looking at the aftermath of a storm might be a few days. But because our data has that limited shelf life, we plan to open source our data sets to the community after a certain threshold. That I need to work out with various stakeholders. But the idea is that maybe after a year or 18 months, anything from our satellites that's been collected that is not sensitive information will be available for the public to use. Build new data sets, use it to find things that were missed, do trend analysis in particular areas. These are all things that can be done with the data, and we intend to open source it.
Perfect, wonderful. Okay, so the next question, Joe, then from my side again, I know I'm giving you many questions, but that's sort of a point here. So my next question is, what role do you see Quub Space and similar companies, maybe not exactly the same, but companies that do remote sensing, emergency response? So how important that is, do you believe, for the future of climate change monitoring and response and the resource management?
Yeah. As far as resource management, you can never have too many eyeballs looking at things. Even if our data just becomes part of a larger data set, it's information that helps you make better decisions. The more knowledge you have about something, the better off you're going to be, right? You can make an informed decision. If I say I've got two cars, one's blue and one's red, pick. That's not a lot of information. But if I say, well, this is a red car, it's made by Ford, hopefully I don't offend anybody there, and it's a sports car, and this one over here is red and it's made by Chevy and it happens to be a truck. Now you have more information to make decision. That's what we're trying to do. So the more information we gather, the better. This helps with climate monitoring. You can never have too much data. We know that there are problems. We know that the climate is changing. We understand how fast it is, but our models are woefully incomplete. The more data we can put into those models, the more accurate we can make those models, the better we can get a handle on this. And we should all be doing our part. And we believe in that fully. We recycle as much as we can. We only use off the shelf. There are no exotics in our systems. So we're trying not to pollute the environment. That said, you really need to have more data about what's going on. And I don't see any downside to that. Yes, there are competitors to us. Planet is I would say, is one of our largest competitors. But there's room for both of us. And the type of data, there's data that they're gathering that is different from ours. But somebody like a fusion company might come, when I say fusion, data fusion company, they might get data from Planet and data from Quub and put it together and create yet a third product. And so the more data you have, the more information, the better your end result will be.
Obviously, and I fully agree to that. I mean, there is always room for, again, improvement, and competition is healthy as long as it's healthy competition and it doesn't become too overcrowded and posing new debris and everything out there like too much. Right? Like we see the plans of tens of thousands of new satellites. And I'm not talking about the small ones, I'm talking about the larger ones. That's just too much, probably, I would say. But again, the governments know what they're doing. They're putting a lot of regulations, including this 5-year deorbiting rule that they have just introduced. I'm sure that has affected the plans for a lot of companies out there that have plans for longer missions. But yeah, so you mentioned that your sats, they have also the propulsion equipped on them. And my question to you is, do you also work in partnership with space situational awareness information provider companies to, again, notify you regarding the possible collision courses, or that you can then use your propulsion system to avoid those collisions?
Yep, we work with Slingshot Aerospace. And they're one of our primary providers for collision avoidance. We also work with the 18th Space Group out of Vandenberg Space Force Base. So we do work with these groups if there is a potential conjunction where two satellites might collide with each other. Yes, we can engage our engine and we can move out of the way. That's a carefully coordinated dance. And that is one of the things that our pilots have to be aware of. I mean, the satellites are pretty much autonomous, but if we have to move one, there needs to be a pilot watching. So our entire ground control system here, mission control, is designed so that if there's a problem in the conjunction data, we can address it very quickly. Our engines are great, but they're very slow, and it's a vacuum arc thruster. It's not a powerful. We don't carry propellants on board like you would think from a rocket. Okay, they're not liquids, they're not gases. It's a solid that we're essentially turning into a plasma. So it works great. It's just slow. So we get a conjunction notice, we can start. We want to act as soon as we get the conjunction notice. So we're tied into those systems. And if you are building a space company, or if you're launching just your one satellite, you need to be involved with these groups. It's just
absolutely that's great advice, and that's why I brought it up as well. I've seen many companies, not thinking that through from the initial phase, and they're okay, let me launch and I'll think later. So obviously they're not allowed to do that because they have to have the plans in place to get the licensing and regulation. But then they realize at the last minute when they get hit with those regulations, right? And you have to comply, and then they have like delays, a year-long delays on their missions as well. So my question for you, Joe, so why did you choose plasma propulsion versus, let's say, electric, right?
Well, it's essentially vacuum arc thruster is we're taking electricity and we're providing an arc across a vacuum space. The fuel is bismuth, by the way. And we take a little bit of that bismuth and we just turn it into plasma. That effect creates more propulsion than just throwing an ion out the back of the door.
Okay.
So plasma is just a little bit better for a propulsive mechanism at this scale. It just electric only propulsion, not a good idea. We don't have room for any kind of fuel tank for ion, so no xenon, nothing fancy. We have to think small. I mean, our entire engine is 42 by 42. Is all my numbers are in millimeters. So 42 by 42 by 14. That's the entire engine. So not a lot of room to work with, but it gives us the delta V that we need to accomplish our mission.
Perfect, wonderful. Okay, so the next question then would be, Joe, from my side. What is some advice, some insight that you would share with those new founders of the companies in the space industry that they need to take into account that is really crucial and you found from your experience?
If you want to get into the space game, you know, the old joke is if you want to make a little money in the space game, start with a lot of money. That paradigm is slowly being chipped away at, and we're proof positive of that. The advice I would give is, if you're passionate about this, that's going to be your key. You better be curious to the point where it could nearly kill you. You have to be curious about this. You have to be willing to dive into things very deep. You don't need a complete understanding of them, but you need to at least have a grasp of what's going on.
Strong. That's strong, because I also oftentimes emphasize that nowadays with the space companies, especially with a bit larger corporations that we see, like they're too much caught up in the money game, in the commercial side and the business side of things, that the passion slowly moves to the second flank, right? It's like fades away a little bit, you might say. And then that's a big issue, like that I see really in the space industry, and that's good that you agree with me as well. And hopefully everybody that's listening to this, those founders, they will reignite their passion once again, and the new ones again, they will start strong with the passion and carry the torch of the passion till the end. So
one other thing I would recommend is have fun. I don't take myself very seriously, but I take my work very seriously, and that is a culture that I've been striving to make happen here. So Fridays at 2:00, all work stops. The work week is done. From that point to 5:00, you may work on any personal project. You can work on. We've got the electronics tools. We've got 3D printing tools. We've got all these wonderful gadgets. Go do something that you are passionate about in addition to the work we're doing. What you gain in experience will only help put better tools in your tool belt, so you'll be a better engineer, a better financial advisor, whatever you need. So we encourage people to have fun. All right. So our chief operations officer, that's Chelsea, and she'll be in there with 3D printing just alongside Nathaniel and Nick. And occasionally we will break out into Nerf gun fights. You know, just have fun with it. Again, take your work very seriously. Don't take yourself too seriously. If you can balance that, then you'll enjoy being a founder.
That's very interesting. Yes, that's great. And again, having fun is very important topic as well. Regarding time management, that's also a fair advice. Obviously, it's sometimes a bit different from what individuals can afford, especially in the early startup days, right? So it's completely different picture in that moment. But yes, it's very important that once you get a chance, you really strike that balance of, having fun and, just this timing as well. The work-life balance is very important still anyways, regardless. So I can speak with you on that. So how large is your team currently, Joe?
Right now, our team is, well, you see on the website, everybody who is here. We have an additional group of advisors. I think we have 7 technical advisors now. We have consultants. We probably have a network of about 20 individuals and small groups that we work with that make all of this possible. It really is about networking. It's about finding those people and asking the embarrassingly dumb questions. And if you're willing to do that, I think one of the gentlemen who works with us, Lloyd Spanberger, he is fantastic. He worked on the Corona spy satellites back in the day. He worked on the SR-71 Blackbird. He put experiments on the X-15. He built his own lasers. This is a guy who knows a lot about a lot. And I am amazed that he comes down here, meets with us, gives us advice, gives us direction, and is having fun with it. And that was a chance encounter caused by a presentation I had given to some students at the Civil Air Patrol. So don't be afraid to put yourself out there. Don't be afraid to look the fool from time to time, because you will either you will look the fool, you'll be the fool.
Yeah, exactly. So you either ask and you grow and you find the answers, or not. And that's very important with the teamwork, especially. I've heard many stories, I've read in many books, the examples actually, that's in the board meetings, they were discussing some subjects, and then one of the individuals asked, so why is that, right? So regarding one of the decisions they made, and nobody could answer actually why is that, right? So and then they went back to square one, and that actually helped them prevent a huge crisis, right, which was going to happen in their company. So that's very important and very good points that you bring in, Joe. I also love the fact that you guys at the team, that you have fun, you do nerve gun fights, so that was fun. What other again team bonding activities do you have within the company that again you could disclose that really help with the team building and process as well?
For team building, I want people to always be learning.
Okay.
So that's a big factor here. So we share different books and different ideas, and we are friends outside of this. We'll go get dinner. We'll go to, now that we can go back to dinner and movies, we'll attend movies. If we don't put one on the big screen here, we do movie nights. But it's really, as far as organized activities, we really don't do that. But if one of my really employees is kind of, that's the official term, but these are people who I consider my compatriots in making this happen. But if Nathaniel comes and says, hey, have you seen the new Mario movie? No. All right, well, let's go see the Mario movie. All right.
That's cool.
It's spontaneous. We keep it lighthearted. All of the group here, they went with me to, okay, I mentioned high power rocketry. There's an annual event on the East Coast called Red Glare. It's where all the high power rocketeers get together and they launch their toys. I said, you guys want to come on down? Like, yep. We piled into a van, threw all my equipment in the back. We went and drove 2.5 hours, launched a couple of rockets, talked with some folks who were launching rockets, made a day of it, drove back here, and just had fun. Didn't think about the office, didn't think about work, just put that aside. So if you're a founder, have a hobby that is unrelated to what you're doing as your business.
I love that. Yeah. I love that what you said, like keeping it real and keeping it like real. That's the important thing, because how many companies can boast that their employees can ask the CEO, like, let's go to the movie, right? So how many companies can say that? Like, I cannot imagine some of those bigger corporations in the space industry. You don't even know the CEO sometimes. You haven't even spoken to him, right? So and obviously that's easier to do with the smaller teams, but just, I'm not a big supporter of this corporate structures. Obviously, it's required when you get on a bigger scale, but just keeping it as real as possible and avoiding those bureaucracies to the point that is possible. So I would, again, also advise that together with you, Joe, to the individuals who are listening and watching this. And yeah, I think with that, we're good to wrap this up, Joe. So if you have any final comments or notes, you can feel free to share them with the audience.
Final notes. It doesn't matter your background. It doesn't matter what you think you are capable of. You can do more than you can do more. You can survive more than you think. You'll be discouraged. accept that discouragement, and then pick yourself up and continue on. You'll know when it's time to give up. You'll be past that point, but don't be afraid. Get out there, do it. I mean, some of the smartest people I know did not go to college.
Yep.
So just go learn what you need, attack the problem, find the right people to work with you, build that nucleus of a team around you, and you can do anything.
Absolutely agree with that. And the important thing while doing that, I would add, is keep your vision, your dream inside and clear, so that you know where you're going, the destination. Very, very vital. And regarding, again, picking yourself up again, and obviously failures, they're part of it. So you should not aim to fail to learn, but you should prevent as many failures as you can. But the failures you take them with stride, and just move on to the success, right? Pivot, make changes as needed.
Try not to fail, but don't be afraid of failing.
Yes,
it's going to happen.
Absolutely, yes. All right, Joe. So thank you so much once again. So let's everybody thank Joe here. And you can learn more about Quub Space on their website. I will remind you once again, Quub.space. So that's their website. And I will also encourage you to subscribe to Altair Insights podcast if you like this episode. Obviously, I'm sure you did if you're watching to this point. And stay tuned for other episodes that are coming soon as well. So thank you all, and I'll see you on the next episode.